Hi, Mr. Rich here. I'm going to work an easy, medium, and hard problem on arithmetic sequences. Here's our first problem, the easy one. This graph gives us several terms of the arithmetic sequence a sub n, and they are asking us to find an expression for an and then use that expression to find a17, which would be the 17th term of the sequence. Well, if you take a look at the terms of the sequence, notice that in this graph, the a sub n's, or the actual terms of the sequence themselves, are on the vertical axis. Their corresponding n values are along the horizontal axis. So that tells me that when n is equal to 0, which will be our first term, its value is 8. The next term is a 6. The next term, it has a y value there, or a vertical value of 4, and so on. So these are at n equals 0, n equals 1, n equals 2, and then we keep going from there. So it looks like this arithmetic sequence has a common difference of -2, because as we move from term to term, that reduction is a constant -2. So there's a constant rate of change between the terms of -2. One thing I would point out about these arithmetic sequences is that they are what we call linear discrete functions. They're linear because the dots that make up the sequence do fall in a straight line, although the function itself, the sequence itself, does not include any points between the dots, right? So the domain of this function is only these integers of 0, 1, 2, 3, 4, and presumably this would keep going to the right. But discrete linear. Now, we said that the common difference here is -2. We call that value D, common difference, for this arithmetic sequence, -2. It is interesting to note that the common difference is going to be the slope of the line that would connect any two of the dots in the sequence. If you take a look at these two dots, for example, at a sub n equal to 6 and a sub n equal to 4, that slope between those 2 points is a -2. If you take a look at the rise and the run between those 2 points, coming down this way is a reduction in 2, going down 2, and then moving to the right +1. That does show me that the rise over run is -2 over 1, -2. That is what we call the common difference. It's the slope of the line that would connect the points of the sequence if we were to graph them. Now, to write the equation for the nth term of the sequence, I'm going to use this form of an equation that you probably have seen in your pre-calculus class. It says that the nth term of an arithmetic sequence can consist of a sub k plus the common difference d times n minus k. Well, the d is obviously the common difference, but this a sub k means that you can pick any of the terms of the sequence and put it in that position to make your equation, but you need to put its corresponding n value, which we call k, right? This would be a sub k. This is k, the nth value of the term. So for this equation, what I could do is I could pick any of these terms in the sequence. I'll pick the one that goes with n equals 1, just to pick one. That would be a value of 6. So I'm going to put, for my nth term equation, the number 6 plus -2, but let's just make that -2 because that is our common difference. And then this would be n minus 1 because the 6 is the first term. And by first term, I mean when n is equal to 1. So that's why we put that there. Could I have written it in a different way? Sure, I could have chosen to use the number 8 when n is 0, in which case I would write the general nth term to be 8 minus 2 times n minus 0, or just n. Those two expressions that I've written for the nth term are equivalent. If you distribute the -2 in this equation here, you'll see that they are in fact the same equation. But now I can use either of those two equations to find the 17th term, or any term. Just plug 17 in for n. That would look like this. Substituting 17 for n, that would give me 8 minus 34, which happens to be a negative 26. So the 17th term is negative 26. This is the medium problem that I've chosen. This says let a sub n be an arithmetic sequence with the following properties. For each of the following, find an expression for a sub n, and then find a sub 11, the 11th term of the sequence. Let's do number 8 on this. Well, we know that if we're going to find the nth term, we're going to use the formula that we saw on the previous problem. I'm going to use a sub n is equal to the kth term plus the common difference times n minus k. Well, the hardest part of this, if you want to call it hard, would be to find the common difference, because I know that I could plug in this point, negative 3 for a sub k, and then the corresponding 2 in for k, but I got to calculate the common difference. Well, the way that I'm going to calculate the common difference is realizing, as we saw in the previous problem, that the common difference is the slope. And it would be the difference between these two values. That's going to be the rise, negative 9 minus a negative 3, divided by the run, which would be the difference between the n values, which would be 6 minus 2. Well, negative 9 minus 3 is negative 9 plus 3. That's a negative 6. 6 minus 2 is 4. So my common difference for this arithmetic sequence is negative 3 over 2. Now we're ready to write the nth term. The nth term of this sequence is going to be, let's choose to use this term here. I'll put in the negative 3 for my a sub k, the kth term, minus 3 over 2. And then because I chose to put negative 3 here, negative 3 is the second term, a sub 2, and therefore this would be n minus 2. Now what I can do is I can find the term that they wanted me to find, which happened to be the 11th term. So a sub 11 would be the 11th term, which would be negative 3 minus 3 halves times 11 minus 2, which I'll just write 9 in for that answer. Let's simplify this. Well, I definitely do the multiplication first by the order of operations. So negative 3 halves times 9 is a negative 27 halves. I will rewrite the negative 3 as negative 6 halves minus 27 halves, and that gives me a final answer for my 11th term as being negative 33 over 2. Negative 6 minus 27, negative 33 over 2. That's our medium problem. For our hardest problem on arithmetic sequences, I've chosen a word problem. This says that across the United States, there are approximately 45,000 flights each day. In a certain simulation, the total number of flights that have begun across the United States n hours since midnight on a given day can be modeled using an arithmetic sequence where 12 a.m. is represented by n equals 0. The total number of flights that had begun by 5 a.m. that day was 11,750, and by 11 a.m. there had been a total of 22,250 flights that had begun. Well, since our variable is the total number of flights that have begun, then these are the terms of the sequence at these different values of n. Well, if n is midnight, that would mean that 5 a.m., 5 hours later, that would be at n equals 5. So the fifth term of the sequence, they're telling us, is 11,750 flights. Then by 11 a.m., which would be 11 hours after midnight, the 11th term of the sequence, there had been 22,250 total flights. So our strategy on this problem is to come up with the general equation for the nth term of this arithmetic sequence, and then plug in the appropriate n value to calculate how many total flights had begun by 6 p.m. that day. So first, we're not going to use 6 p.m. We're not going to put that into our equation until after we've gotten the formula for the nth term. Well, we're going to use this as our template to build this equation for this sequence. A sub n is the kth term plus d times n minus k. Our first task really is to find the common difference. Well, hopefully from the previous two problems, you can see that the common difference here is going to be just a slope calculation where I find the difference between these two terms of the sequence, which will be 22,250 minus 11,750. That represents the rise, the change in the amount, but it took place between 11, 5, and 11, so we do 11 minus 5. I'm going to use Desmos to do this. Over here in Desmos, I am going to put 22,250 minus 11,750 over 11 minus 5. I get 1750. I want to show you how it would look on the TI-84. If I were to do that calculation on the TI-84, I could make myself a fraction, and on the top, put 22,250 minus 11,750, and in the bottom, put 11 minus 5, and there it is, 1,750, consistent with what we got in Desmos, 1,750, common difference. Now we can build the equation that represents the nth term of this arithmetic sequence. I'm going to say the nth term will be, let's use this first number of flights that occurred at n equals 5. So we'll plug in 11,750 plus the common difference was 1,750 times n minus 5, because the 11,750 is the fifth term of the sequence. That's it. That is the equation that I would present as the representing any of the terms of the sequence. But now we got to figure out how many flights had begun by 6 p.m. So we got to consider how many hours after midnight that would be. Well, midnight to noon would be 12, and then we add the 6, that gives us 18. So we're looking for the 18th term. So we do 11,750 plus 1,750 times 18 minus 5. We can go to our TI-84 to do that. And we'll do 11,750 plus 1,750 times 13, 30,500, 34,500 flights had occurred on that day by 6 p.m. Total flights by 6 p.m. Class, I hope that helps. That is arithmetic sequences, easy, medium, hard. Catch me on the next video. Take care. Bye.